Okay. Good morning, everybody. It's time to get started. Um, first well, I guess there's a lot that happened since the last stand-up, since it's been nearly a month now. Um, and I will start from the top, schedule-wise, or I could do this reverse chronologically, but what is the... Okay, that's a major tangent. Too early to go defining what is the top of the list. Anyways, so the biggest thing, of course, is that we have done a rebranding from Peggy to Gravity, and this is really a choice that we've made to get away from the whole Peg Zone name, as Gravity is not intended to be run on an independent peg zone with all funds transferred by IBC like the original Peggy concept was intended. Instead, Gravity is designed to run directly on a high value chain like the hub and facilitate efficient value transfer at scale without requiring all of the complicated delegated. Essentially, you need a lot of staking derivative style stuff to make Peggy as it was originally envisioned work, and we're not doing that. We're making a hub directly for the bridge, so we decided we would call it Gravity. Sorry, a hub directly for the Cosmos, a bridge directly for the Cosmos hub. So yeah, that's sort of the renaming. Same project, same code, different name. Uh, Not too much else going on there. Um, Now, let's cover what's actually happened to said code since our last stand-up. And last time we were mostly covering the first testnet. Um, and I mentioned that the next thing we would be working on is slashing conditions. So I am happy to announce that slashing is complete and for the most part tested. It still needs a little bit more. Still needs a little bit more polish and inspection, and a testnet to really stretch its legs. But how it works is that there are three ways you can potentially be slashed as a validator by not doing things that the gravity bridge requires you to do. Um, so, as a validator, you are expected to. Yeah, sorry for the early hour, but you see, people ask for a later meeting, but they don't show up to the later meeting. So, and I'm on the East Coast, so haha. Um, Now the yeah, so there are three slashing conditions. Um, the two most important things that a gravity validator does, which, by the way, a gravity validator is the same as a regular Cosmos validator. Every validator on the chain also works with the gravity bridge and performs these required actions, or they get slashed, which is part of what I'm explaining now. Um, so the things you are required to do is you as a validator must have access to an Ethereum node that you trust, and use that to observe events on the Ethereum chain and carry them over to the Cosmos side, where these events will be signed with a key that you create. Um, and so you register this key and you say, hey, this is. So the next major subject that we managed to make our way through in the last month is that Jahan and I modified the way. So Jack and I did slashing. Jahan and I modified the way events coming from Ethereum are processed to be more efficient. Um, and and what we mean by that is that previously, the validator who actually finished the event. So when an event happens on Ethereum, all the validators submit a transaction with that delegate key I was explaining before. Um, and when more than 66% of the active voting power says, hey, this event has occurred on Ethereum, tokens are minted, batches are released, etc., etc. Um, and previously, the person who pushed that vote over the edge was the person who paid for the entire operation. Um, this caused a number of problems because actually executing the logic with that person's vote created order issues, etc. That's all been moved into IntBlocker now, since Jack was kind enough to set up an IntBlocker for slashing. So it was just the logical place to put it. Um, there have been a number of improvements to the relayer, Ethereum signer, and other things as well. And then, sort of finally, we can get into the Peggy v2 work that is, sorry, Gravity v2. And everybody's going to be making that mistake for months, I tell you. So the Gravity v2 work that Jahan has been working on. Now, he's here right now, so I don't know if he has the time to talk about this or if he wants me to cover it.
No, I can cover it. So basically, I don't know if we've covered this before on a stand-up, but the way that Gravity V2 will work is what it does is it allows Cosmos assets to be represented by ERC20s on Ethereum. And so what that means, there needs to be an ERC20, which when you send it into Gravity, the validators will will unlock Cosmos assets for you. So the way we do that is we allow people to call an endpoint on the Gravity contract, which deploys an ERC20 contract, and they specify what the the metadata, so the decimals and the symbol and stuff like that, which makes it look nice in wallets. And when that's deployed, an event is fired and is picked up by the same event oracle as everything else. And when that event is processed, then the validators basically check that the metadata is all correct, has a correct symbol and all that, and then they check the correct symbol, the correct decimal points, everything, and then they put it into a mapping with Cosmos asset to Cosmos denom to ERC20. And then what happens is if you send into the Gravity side of the bridge, you send Cosmos tokens. It first looks up it looks at that mapping and tries to see if there is an ERC20 for that, and if like an ERC20 representing it. So if there is, then it will use a batch for that. But if there's not, it goes back to the normal thing it does, which is to try to get the address out of the Peggy denom. And then on the way back in, so when you're sending into the Gravity contract from Ethereum, that just gets fired off as a normal event. And when that deposit event comes in, the same thing happens in reverse. It sees if there's a Cosmos asset for that ERC20, and if there is, it unlocks Cosmos tokens for you. So it's pretty much just an alternate path where you, instead of like the Peggy, right now the Peggy denom has the ERC20 address embedded in it in the string. This is an alternate path where it can be looked up because obviously Cosmos assets have their own denoms and they don't have the ERC20 right in the string. So it's pretty much how it works. It's kind of deceptively, almost deceptively simple, the way it works. That's all that's needed.
Yeah, so the current state of Peggy v2 code-wise is that we have the solidity changes in master, but not the rest of the Cosmos logic. So it's going to need some more testing before it's ready for use, and this sort of gets to the state of the bridge code-wise right now, which is that transfers of Ethereum-based assets to and from Cosmos work and are tested, Um, and the being able to maintain control of the bridge is also tested. Um, we really need to wrap up an audit and test slashing, and the bridge will be usable in good conscience. If you were at the moment, I would say that you are fairly likely to not lose the funds in the bridge. Not that that is financial advice, and you use gravity at your own risk, but but you're fairly likely to be able to run gravity and not lose the money. But you very well may have downtime downtime where the funds in the bridge are inaccessible until you can rally up your validators and get things back running again. So that's what we hope to fix with more testnets. Um, and of course, an audit will provide more confidence in the overall logic of the system. But the good thing about Gravity's design is that barring a egregious vulnerability in the Solidity contract or in the Go code, only the validators are really have much attack surface, which certainly isn't nothing, but it's a good bit better than if just anybody could seriously take a crack at manipulating the bridge operation. Um, yeah, I think that covers. Oh yes, schedules and timelines. Um,
Yeah, I was gonna say if folks do want to take a crack at seeing if they can break or steal the funds on the bridge, we will have incentivized testnets. Probably looking at March for that.
yeah, I would say at this point that we could have a slashing testnet at any time, and that's sort of a coordination decision. Um, but chances are that for the sake of testing more stuff at once, we're going to want to try and get the rest of Peggy v2 sort of rolled in and ready for testing, and go for a non-incentivized slashing Peggy v2 stability testnet towards the end of the month, towards the end of this month, February, and then a all-up incentivized testnet um, sometime in March. After that, we set off the fireworks and everybody's off to the races. So yeah, that's really the plan, and I think we'll
Well,
take the.
yeah. The other thing I was gonna say is after the incentive assessment, we'll be working to bring a proposal to the hub. So that will kind of be the timeline for after March. Late spring this year.
Yeah. Um, yeah, so proposal to the hub, actual deployment to the hub, integration with Gaia, all of that is coming up after the software is theoretically ready for a chain to deploy. Um, so I think we'll spend the rest of the stand-up time answering questions if anybody has any. And feel free. Um, no, I think that's pretty much all I got.
Is there
And
any thought about another like half 4 hour, when the next 4 hour sort of sit down working session might be?
Yeah, I'm thinking mid to late this month. It sort of depends on when we can get Peggy v2 finished. Well, not finished, but merged enough that we can theoretically start testing it, and then how quickly it takes to round everybody up after that. Because you got to give everybody about a week of warning. So, and yeah, that's really the conclusion there. We'll be spinning up another testnet. We're going to do another 4-hour video session on it. We already have the documentation, so I think it'll be much smoother. And then we're going to try and keep it running for as long as we can, and see what it takes to break it. Because
Awesome.
next we're doing the incentivized testnet. So we sort of don't want to. How should I put it? It's no fun if somebody breaks the chain right away in the incentivized testnet.
All right, thanks, Justin.
Is anybody looking into a Kubernetes deployment for the Dockerized version of the validator?
I don't think that's So I mean, that would be more of a Cosmos-based question than a gravity question. Or are you talking about running some of the gravity components in a Kubernetes cluster?
Basically, I'm learning the whole collection of components at this point. So um, there was something like a Helm chart that would cobble everything together and make deployment easy. That would help with onboarding and participation, I would think. It could also, on the other hand, there's a fair bit of abstraction when you do something like that. So it might cause people to get stuck and dead in the water unless it was a really tightly done integration.
Yeah. So right now we just have a pretty simple. Um, right now the documentation just runs people through running the three different processes you need, which is that you need um, you need an Ethereum node, preferably a light client, or you're going to have a bad time trying to run that. You need the ETH signer plus relayer, which we call the orchestrator, which is the only gravity-specific component of this, as it talks between Ethereum and the Cosmos SDK. And then you need the Cosmos SDK, like any Cosmos-based chain. Um, I think having those in some sort of Docker Compose like setup or Kubernetes like setup, something that just spins up a couple of containers and wires them up, um, it certainly has some value. Um, the the issue is just taking the time to do it. So if anybody wants to volunteer for that, that would be great. Um, and if anybody needs help figuring out how to run these components, I'll be happy to share the testnet documentation we have, and I'm free for questions all the time in the Gravity Bridge channel in the Cosmos Discord or in the Althea Validators channel in the Althea Discord.
Cool, thanks.
Hey, can you elaborate on, you mentioned you said you'd have a bad time if you didn't run a light client. What do you mean there?
What I mean there is that trying to run an Ethereum full node, um, you're going to need at least 300 gigabytes of SSD space, and that is, how should I put it?
Oh, okay. So if you don't have a node already, then it's that kind of hurdle. It's not
Yes.
the load that's going to be induced necessarily.
No, 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 no. It's not going to
Okay.
be the load that's
Okay.
load that's induced, and this should take me to sort of something that we need to cover, which is that Ethereum nodes are somewhat difficult to run. They require a few days to sync, fairly sizable SSDs. They put a lot of write load on your SSDs. Um, and that is if you are actually going ahead and disabling ancient block sync, which I typically do on my nodes to keep the storage down. Um, and that is actually not widely recommended because you're not keeping old blocks. You can't actually query old blockchain state. In this case, it is sufficient for the. In this case, it is. In this case, it is sufficient for running the gravity bridge since we only need present state and a little bit of past state. Um, but what I would like to do is encourage everyone to run Geth-like clients because here's the thing. The actual requests being made are not that intense. You could maybe have two serious full nodes serve the requests of a 100-person validator set. The issue is trust. They can't all use Infura because then Infura effectively controls the bridge. Infura couldn't spend funds, but they could censor things in the bridge. Um, um, so the light client problem. So the light clients actually verify the requests against the full nodes and sort of removes the trust. They also sync in a matter of a few minutes rather than a few days, and are generally much more lightweight. Um, and I think the structure I would like to encourage for people is to have a light client that they actually make their Ethereum requests against, and to run their own full node separately and make sure it peers with the light client as necessary. And the reason that I recommend this is because if your full node goes down and you need to resync the blockchain, you're going to be SOL for days. And you're guaranteed to get slashed for downtime because you can't Oracle events from Ethereum during that time. So any serious validator would either need to run multiple Ethereum full nodes themselves in order to have a failover condition, or they should use a light client, and that way we can share the full nodes, because it's not actually a load problem, it's a trust problem. So this is something we are working on a bit with the ICF. We're going to try and get a cluster of volunteer full nodes and some that we run ourselves, and a peers list for Cosmos validators to use, where they can simply provide this peers list to their Geth Lite client, which will then, so what the Geth Lite client does is that it forwards the requests off to several full nodes, compares their responses, and does headers checking where possible. So this should be a secure and more efficient way to run things that also deals with the sort of strict uptime requirements that Ethereum nodes are not very nice about.
Yeah, I think
That's
that is what I was looking for. I know that there are at least 3 people in here that are running full nodes, and so good. That answers it. It really, yeah, that really answers what I was just wondering why you made that comment, and I think that explains it well. Thanks.
Yeah, and Justin, that idea of having a full node backed up or side by side with a light node, then that's a really good idea for failover. The same group of people that Nick was just referring to is we've got a strategy for failing over to each other's nodes. So let's say I lose my main Ethereum node, I could remotely over the internet attach to his, and vice versa. We haven't actually run through the fire drills of testing that, but hopefully that'll happen pretty soon.
Yeah, so how should I put it? The libraries that we use for the Gravity Bridge, orchestrator, and talking to Ethereum are the same ones that we use for our Althea routers. So they're designed with really high availability in mind. And what it will actually do is that if you have a DNS entry with multiple A records, it will intelligently parse the A records and load balance traffic across the entries. So you can do a very simple load balancer setup where you have, let's say, 5 or 6 full nodes or light clients or whatever behind one IP address, and it will then fail over the traffic. And even if all of them are down, it will eventually find all but one are down. It will eventually find the one that is up, complete the request successfully, and that will happen long before you get slashed. And this is well proven behavior in the field. So that's one of the reasons we decided to design this the way we did.
You
Cool.
mentioned earlier the idea of running basically a gravity validator would be equivalent or similar to running a Cosmos validator, and I'm curious, does that mean that you would basically, well, I looked into running a Cosmos validator, and there's a fairly high amount of capital investment required, or at least that was my impression. Do you have a sense for, would that be the same for running a gravity validator, or would it be different? And if it's different, do you have a sense for what, if any, like kind of serious capital investment it would require in terms of staking or that sort of thing?
Okay, yeah, so there's a lot to unpack there. First and foremost, I should say that a validator for Gravity is identical to a validator for Cosmos. So if you're validating on a Cosmos chain and that chain is running the gravity bridge, you are also doing validator specific tasks for the gravity bridge. So just imagine that the bridge takes all the normal things you have to do to be a Cosmos validator and attaches some more tasks to that same entity. There's no now thinking of them separately and thinking of them the same sort of happens because you're doing a bunch of things that are specific to the gravity bridge, but those can only be done and must be done by all members of the Cosmos validator set. So they're the same thing. Once you are in the validator set on the Cosmos chain running the bridge, you have to do all this gravity stuff too. Or you lose money when you get slashed. And by the way, slashing by default at least is not a huge amount of money. So now the capital requirements for running a validator, that really depends. Theoretically, you can run a validator and do so well on a very small machine, a simple desktop in your house. The issue is sort of the risk versus sort of the risk of downtime versus the cost you want to put into it. Now, there are lots of validators that are, how should I put it? The validators that give you the impression that it is extremely expensive to run a validator are the ones that are out there trying to get other people to delegate their stake to them. So that means that it's like, hey, you have $1 million in Atom. Why don't you delegate it to me? And of course, when you say that, you have to convince those people that they aren't likely to lose a few percent, because slashing is, it's not like you lose all your money, but you could lose money if that validator misbehaves. So that's a serious risk, especially when we're talking on scales of large amounts of capital. So those validators are trying to convince everybody that there is no chance that they'll go down. That all being said, the actual downtime period is quite long. We're talking, I think it's more than 8 hours. I think it's at least 16 hours because you're supposed to be able to go to sleep, wake up, go to work, and then get your validator back up is how it was set. So we're not talking really tight timelines. I wouldn't say that you should run a validator anywhere where your internet is regularly going to go out for longer than a day. But if you have a reasonably reliable fiber line with an SLA, which is any business does, and you are physically present nearby your machine, then, just pick a reasonably reliable box, have a backup box, it can be a $100 desktop, and you have a backup $100 desktop. Now, are you going to get everybody to delegate $1 million to you this way? No. Are you going to run a reasonable validator and have the same or probably lower risk of being slashed as somebody who has a ridiculous $10,000 power strip in their giant data center? In fact, you're probably a little better off because if the validator's in your house, you're definitely going to know when somebody tries to break in to steal its keys, rather than in a data center. Although data center security is pretty serious, so I'm not knocking that. I'm just saying that, so I guess to sort of tie up my statement, there are many ways to run a validator. There are risks, and I'm not saying that there aren't, to doing it more cheaply than the way people typically talk about. But if you look at the real requirements, which is that you have to have a machine, you have to be around to monitor it, and the machine can't be down for more than half a day. That isn't terribly difficult to achieve. You certainly don't have to spend $30,000, $40,000, $50,000 to achieve that.
Cool. Thanks for the explanation.
And for what it's worth, you can get an Ethereum node running on a Raspberry Pi with fast SSD attached. So that's $200.
Yeah, I think my impression came from some of those websites. So like, what does it take to run a Cosmos validator? And they were more focusing on what does it take to be in like the upper, whatever, the top 10% of validator nodes to, and like you said, it's in order to attract staking interest from other people. So Thanks for clarifying that. So, but for Althea, like if I'm interested in running a validator node for the Althea chain, I'm not necessarily going to need to look at it through those lenses, but it's more in the realm of what do I need to do to have a degree of confidence for myself in the security and the uptime. Yeah. So
Yeah.
thank you.
So, and it's also important to remember that while it is that while it is important for the chain, um, that while it is important for the chain to not have too many validators go down or be insecure or etc., um, large professional validators are not necessarily the best way to do that exclusively, as they are more likely to be victim to systematic failures. So let's say the biggest internet exchange on the West Coast goes down. Like that may take out enough of the chain to actually, that may take out enough of the stake to actually halt the chain. So for the Althea blockchain, what we're going to try and do is encourage a diverse community of many smaller validators, and we're going to spread what stake we have, sort of as evenly as is reasonable. Because obviously we don't want to put how should I put it? We don't want to put our money on a validator if it's literally a hanging PC collage from somebody's ceiling. But our standards are not hugely higher than that, because our goal is the maximum resilience of the chain. And you don't and like I was saying before, you do stand to lose some money, but you're not going to get wiped out if somebody you delegate to gets slashed. So we would rather there be more validators on more diverse hardware in more diverse locations. Because that's what's better for the chain overall. Well, for any individual validator, it would be great to spend $50,000 or whatever. The whole point of a distributed system is that it is distributed, and that the reliability is not dependent on any individual node. And what you really care about is avoiding correlated failures rather than, like, oh, everybody's using the same model hard drive. Oh, everybody's using the same server. Oh, no, everybody's actually on the same fiber trunk line. They just don't realize it because they're all wired into it over like 100 different miles. These are the things you really need to think about when you're running a large distributed system. Not necessarily is any individual node have dual power supplies or whatever, because 18 hours is plenty of time for you to go and plug in another machine. Cool. If that's all the questions today, I'd like to thank everybody very much for coming, and we will get back to you. What is the amount you'd lose if you were down for 60? That is up to the individual chain, and I do not remember the amount on the Cosmos Hub off the top of my head. As for what we will set it to on the Althea chain, I am hoping to get that sort of parameter set up in the next couple of weeks, and we can all talk back and forth about it. But I don't think downtime slashing should be more than a couple of percent. There's no reason to be too harsh for it, and frankly, people are maybe too afraid of it already. So, no problem. Yeah. Yeah, something ridiculous. Cosmos, so Fabian said that he thinks on the Cosmos Hub it's either 0.1 or 0.01%. And yes, that would line up with my memory at least. It's something really absurdly small for everybody to be so, well, okay. Once again, validator culture on Cosmos is has a lot to do with what these big professional validators project as they try to get people to delegate to them. So for them, being slashed for downtime, no matter how small the slashing is catastrophic, because nobody's going to show up to delegate their funds to them again. and they can't justify, well, why are we collecting fees off of what should be your delegating rewards if we're going to go down? So I think the social dynamics, at least on the Cosmos Hub, have ended up in a place where everybody is so afraid of being slashed that the actual amount of capital at stake is often not considered because it's not enormous. Well, I mean, the amount of capital at stake is enormous, but the amount of capital to be lost for something like simple downtime slashing is not. It's not the end of the world. So yeah, I think that covers everything, and I hope everybody's a little bit more informed about what we want out of the Althea validator set, which is above all sort of a diversity and decentralization rather than $1,000 power strips. Although I have it on good authority. It's a very nice power strip. Okay, thank you everybody, and I will see you hopefully in just a week or two for our next testnet.